there any questions on the homework assignment that's due on Sunday? No. Okay, so that's due on Sunday. You do not need to do the project for Sunday. That's not due until October 10th. So you just have to write a paragraph explaining what you think you're going to do your project on, how you're going to gather it, the type of relationship you think you're going to find. And then once you do start the project, if you change your mind, that's fine also. It's just to make sure you have the right idea. Any questions? Okay. We started 3.2 last class. In fact, we finished up through number 4, so we're on number 5. So today we'll finish 3.2 and start 3.3, and then next week we'll do 3.3 and 3.4. So the homework from my labs that is due this week is 3.1 and 3.2, and then next week 3.3 and 3.4. On my labs, when you're working on the homework, if you say it's not at 100%, if you want to go back and keep working on problems, you can. So even if it's past the due date, you can still work on them and bring them up. Or if you didn't get one done, you can still finish it. You have until the end of the semester. So September, number 5. We were on 5. The total revenue for a home theater system is R of X equals 266X. And the total cost is 2,000 plus 46X plus 2X squared. Revenue and cost are in dollars, and X is the number of home theater systems produced and sold. The first part asks us to find the profit function. Profit is how much money you bring in, your revenue, minus how much it costs to get those items. So profit is revenue minus cost. Our revenue is 266X minus our cost, which is 2,000 plus 46X plus 2X squared. The most common mistake on this is to write it the way I just wrote it, because you want to subtract all of the cost, not just the 2,000. So that negative needs to be distributed to the entire cost function. So be careful of that. Distributing the negative, we have a negative 2,000 minus 46X minus 2X squared. And then combine like terms. Negative 2X squared plus 220x minus 2,000. Any questions on the profit function? Part B, what is the profit? Oh, sorry. When 55 systems are sold. The number of home theater systems is the X value. So we're plugging it in for X and we're plugging it into the profit. And then we calculate it. Is there any questions? Negative. Are you getting 4,050? So if we produce and sell 55 home theater systems, we will make a profit of $4,050. Any questions on that? Okay. Break-even quantity. When we're looking at the break-even quantity, there's two ways we can find it depending on what information we have. You can set revenue equal to cost, which we have, or you can set profit equal to 0. Both of them will give you the same answer. If we set revenue equal to cost, then because this is squared, we still have to get it set equal to 0. So we might as well just use the profit function and set it equal to 0. But both ways you will get the same answers. So I set the profit equal to 0. It's already set equal to 0. We could use the quadratic formula, factoring by completing the square. I am going to factor this one and then use the quadratic on the next one so you see both. The other thing I noticed is this 2 will divide into all of my terms. I have 4 terms here. You can only get rid of it when you have an equation and you divide everything by it. If I didn't have the equal to part, I could factor the 2 out, but I couldn't actually divide and get rid of it. But when you have an equation, you can. You can divide each term by a -2. You get x squared plus, so that should be a minus 110x plus 1,000 equals 0. Any questions so far? Okay, if we factor this, there's no number in front, so we multiply to get a positive 1,000, and we add to get the negative 110. Well, I know 1,000 is 100 times 10, and if I add them, I get a positive 110. I could make them both negative, and then when I multiply, I still get the positive 1,000, but then when I add, I do get the negative 110. No number in front. So we have x minus 100 and x minus 10. Any questions so far? Setting each of them equal to 0. We get two answers, 10 and 100. Well, the reason is because you're breaking even in two different spots. Because break even is where the two lines, your revenue and your cost, intersect. Because this one is a parabola going up because the A is positive. And this is a straight line that's growing because the slope is positive. So if we looked at it, we have a parabola, and this is our cost, and then we have the revenue cutting through it. Where they intersect, that's the break even. So this one was at 10, and the other one is at 100. They call this one minimum break even point because that is where you start making money. So the minimum break even point is 10. And that's where, notice this is the cost function. Notice here the revenue is above the cost. This is your profit. So right here, you are no longer in the red. Revenue is above cost. Minimum break even. The higher break even point, notice that revenue is down here and cost is up here. Cost is a lot higher. This is when the next system has to come out. So PS4, if this was a PS4 at 10 units, or maybe it's boxes, whatever X stands for, but at 10 of them, that's where you start making money. This here at 100 is where the new system needs to come out. So this one was home theaters. 10 home theater systems and we start making money. After 100, we start losing money. It's not selling like it was. And that's when the new product needs to come out. Any questions on that? Okay, so this is your minimum break-even point, and this is the other break-even point. There's not always more than one, but any questions? Number 6. The demand for diamond-studded watches is given by P equals 7,000 minus 2x in dollars, and supply is P equals 0.01x squared plus 2x plus 1,000, also in dollars. Where x is the number of watches demanded and supplied. So x is the diamond watches. Find the equilibrium quantity and price. Equilibrium quantity and price. An equilibrium is when your demand and your supply are the same. Your public demands the same amount that you are supplying. So we set them equal. They're both already solved for P, so we could substitute the one into the other and have 7,000 minus 2x equals 0.01x squared plus 2x plus 1,000. Again, we have the x squared, which means we have a quadratic, so it needs to be set equal to 0. Any questions so far? I like to keep my squared term positive, so I would bring the 2x and the 7,000 to the other side rather than moving these three. So I would add the 2x and subtract the 7,000. And as long as you keep them lined up, you can move them both at the same time. But these both cancel and leave 0 equal to 0.01x squared plus 4x minus 6,000. Any questions on that? You could multiply everything by 100 to make this a 1, but then these numbers are getting large, so I would just use quadratic formula. Here's the quadratic formula. A is with the squared term, so it's 0.01. B is with the x term, it's a 4. And C is the constant, it's negative 6,000. Using the formula, x equals a negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Once you plug it in, calculate under the square root. Under the radical, you should get 256, which is nice because it's a perfect square root. But is there any questions so far? (256) negative 4 plus or is the square root of 16 over 0.02. So you do the plus and the minus at the same time. So this one I'm going to add, and this one I'm going to subtract. Negative 4 and 16 is 12. 12 divided by 0.02 is 700. Negative 20 divided negative 20 divided by 0.02 is a negative 1,000. Is there any questions on that? Now we wanted X is the number of watches, and that's what we found, X. Well, it doesn't make sense to have a negative amount of watches. So it's 700 watches. Will give us an equilibrium. Now we still need to find the price because this would be quantity. Because that's our X value. Price. You have two equations. You can use either one. You're going to get the same answer no matter what you use. First one looks like a lot less work. So equilibrium quantity is 700 watches and the price is $5,600. So if we sell the watches for $5,600, we will sell 700 watches. And that's where your supply and your demand are at an equilibrium. Any questions on that? Section 3.3 is piecewise functions. They call them piecewise because we break them into pieces. For one part, you graph one and then use a different one for another. So they're called piecewise functions. Okay, so the first piecewise function is x squared minus 1. Now this is the equation we use if x is less than or equal to 0. So when x is less than or equal to 0, we use this one. For the other one, we use it when x is greater than 0. So the first thing you do is see where your x value falls, and then use which one it comes in between. So it's asking us to find f of 1, 0. It's asking us to find these. So for the first one, we have to decide which one of the equations to plug into. If we look at this is where x is less than or equal to 0, while 1 is not less than or equal to 0. 1 is greater than 0. So we use the bottom one and plug in. 1 cubed plus 2 equals 3. Any questions on that? The 0. When we look at both of these, notice this one has the equal to. That means including 0, where this one does not. So we're using the top row. When we plug in 0, squared minus 1, which gives us a -1. Any questions? Okay, the last one, f of -2, when we look at both of these, notice -2 would be here because -2 is less than or equal to 0. So we use this one. -2 squared minus 1. 3. -2 squared is 4, minus 1 is 3. So we get 3, -1, 3. Any questions on that? To graph it, we use Desmos. And I brought it up already. I'm just in the main screen for graphing. And we'll put that first one, x squared minus 1. X, the up arrow will move it up for you. And we put squared and then come back down, minus 1. And I forgot the equals y. There we go. So we have a parabola. Now, in order to use the piecewise part where it said, in this one it said if x is less than or equal to 0, what you use is the cursive parenthesis. And you put x, it was less than or equal to 0. So notice it's only showing you when it's less than or equal to 0. Any questions on that part? I hit enter so the next one would come up. The next one, y equals x cubed. Oh, I need cubed. X cubed plus 2. And then the script, x greater than 0. Notice the parabola, well, so x cubed kind of looks like a snake, but we only want the part where it's from 0 greater than 0. And so then when we write that in, x greater than 0, it took away the part we didn't need. Another thing, this one doesn't have the equal to with it, this one does. So if you notice when you go over to the point, whoops, I have to hold it down for it to stay, but it's undefined. That's because it can't equal 0. We have just greater than 0, where this one would be okay. It has it because it has the equal to. This one does not. Do you have any questions on the graph? We're going to do another one. Okay, the other thing I want to mention on the graph, I'm not sure if it's in the next section or chapter, but when we get to limits, when you're tracing this, notice here we have to lift our pencil if we were tracing. It jumps. So whenever there's a break in the line, it's not continuous. So in this one, it's not continuous at x equals 0 because there's a break in the line. And this one, because it doesn't have the equal to, would have, if you could see it when I click on it, it would have an open circle. Any questions? Okay, let's go to the next one. There's no questions? Oops. So for the second one, find f of 6, f of 4, and f of negative 6. And whoever finds it first, enter it in the chat. For the last one, oops, let me bring my paper up. I would have put 3 comma negative 1 comma 3. So find f of 6, f of 4, and f of negative 6. So go ahead and find all 3 and then put it in the chat. Okay, f of 6 is negative 2. F of 6, we'd use this one because 6 is greater than or equal to 4. 4 minus 6 is a negative 2. Got that one. Nice job. Okay, go ahead and find the next one. F of 4 is 0 and f of negative 6 is a negative 10. Those are correct. Now notice the f of 4. Should we use the top or the bottom row?
Bottom, because it says less than or equal to, or greater than or equal to. I'm sorry.
That's okay. You're exactly right, though. It has the equal to part. And so that's the one you would use. Now, in this problem, notice it doesn't matter which one you use, you get 0 for both. What's happening is it's making it continuous because both of them are going to meet at 0. Whereas the other one, if you plugged in 0 into both of them, you're getting 2 different answers, and that's why the graphs were separated. But when we graph this one, you'll see they come together because both of them give you the same answer. Although technically you should use the bottom one because of the equal to part. And then the negative 6 is negative 10. That is correct. Because negative 6, we'd use this one. Negative 6 is less than 4. And so we would use this. Negative 6 minus 4 is a negative 10. Any questions on those? Okay, let's go over to Desmos and graph it. So it's x minus 4 if x is less than 4. 4 minus x if x is greater than or equal to 4. Okay. Throw this triangle. Not triangle. V. It doesn't connect on the bottom. But notice that the two endpoints converged or went together. That made the graph continuous. So this graph is continuous. And that will color in this point because the equal to part would be a colored in point. The other one would be an open circle, but it fills it in. The green one fills in the red line. Any questions on that? Is everyone okay with the graphing? Okay. Number 3. The formula that gives the wind chill factor for a 60-degree Fahrenheit temperature and a wind with velocity v in miles per hour is given by these formulas. And so what it's saying is, on a windy day, if it's 60 degrees, and then the velocity of the wind is between 0 and 4, it will still feel like 60 degrees. But once you are at 4 or above, up to 55.9, you would use this equation to find it. And then once you get above 55.9, it will always feel like 41 degrees. So if the wind got any stronger, it's still going to feel like 41. Okay, let's try a problem. Find the wind chill factor for the 60-degree temperature if the wind is 20 miles per hour. Well, it says that V is miles per hour, so the 20 is our V. Would we use the top, middle, or bottom equation? Anyone? You want to see which one of these ranges the 20 falls into? Top, middle, or bottom?
Middle.
It's the middle one because 20 is between 4 and 55.9. So we use the middle. 0.6. Minus 9.518, excuse me, square root of 20, sorry. Okay. So we're plugging the 20 into the equation. Then you just plug that into your calculator. You're getting 46.8 degrees, 47, or yeah, 47. So if the wind is going 20 miles per hour on a 60-degree day, it's going to feel like it's about 47 degrees Fahrenheit. Any questions on that? Find the wind chill factor for the 60-degree temperature if the wind is 65 miles per hour. What would the temperature be if winds are going 65 miles per hour? Anyone?
41.
Mm-hmm. Because 65 would fall in this bottom one. It's greater than 55.9, and so the temperature would be 41 degrees. Any questions on that? Okay. Number 4. For the non-extreme weather months, the electric company charges $7.10 plus 6.747 cents per kilowatt hour for customers using up to 1,200 kilowatt hours. So if you use up to 1,200 kilowatt hours, this is what you get charged. And charges $88.06 plus 5.788 cents per kilowatt hour over or above 1,200. So it's $7.10 plus 6.747. This is in cents. And the first part of the question says write a function that gives the monthly charge in dollars. So I'm going to change this to dollars first, both of these. 100 pennies is $1, so you just divide by 100 or move your decimal over 2. That way they're all in dollars. Now if we look at the first one, $7.10 plus 0.06747 per kilowatt hour. So times the kilowatt hours. We'll let X be kilowatt hours. And that's up to 1,200. Well, of course, we wouldn't go below 0, so it's from 0 to 1,200. And the other one, or is there any questions on the first one? No, I included the 1,200 here because it said up to the 1,200. Here it was over 1,200, so at 1,200 it would use this one. Or it said above 1,200. This one is 88.06 plus 0.05788. Now it's not going to be X because it's the hours over 1,200. So it would be X minus 1,200. So anything over 1,200 would get this for the extra part. So they're kind of giving you a discount. And this is when, I should put if there, X is greater than 1,200. So everything over 1,200, you pay this amount on. Any questions on that? So A was just the equation. What is the monthly charge if 960 kilowatt hours are used? Well, the first thing we want to do is decide which equation to use. Well, 960 is between here because it's less than 1200. So you'd use the top one. So it costs $71.87. Any questions on that? Okay. I wanted to show you something before we do part C. The 1200, you know how I said it makes things continuous if they're the same? Well, when you put the 1200 in there, you get $88.06. And that's where they came up with this 8806. That's using 1200 of them. And that's why this charge, you get a little discount after the 1200. Instead of paying the full amount, you pay this much. But that's only on the part over the 1200. And that's why you have to subtract it. And C wants to know 1580 kilowatt hours. But is there any questions so far? 1580 is definitely over 1200. So we would go by this price. 8806 plus 0.05788 times 1580 minus the 1200, and then we plug that in. And you should get $110.05. Any questions on that? If we put the 1500 into the regular charging price, put it in right here, it's $113.70. So you're saving a few bucks. Is there any questions on that? Positive. Okay, the next one has a lot of parts to it. Well, not a lot, it has two, but I don't want to try and rush it in. So we will stop there. Does anyone have any questions?